Question number 1. What is meant by electric field? Okay, actually, electric field can be defined as electric force per unit positive test charge. So this is the definition of electric field. Next, 1B. Figure 1 shows two isolated charges positive Q, negative Q, equal magnitude. Alright. And then sketch electric field line produced by these two charges. So we need to consider a few things. 1. The magnitude. Equal magnitude means 1 and 1. Okay. 2. The sign. Positive, negative. So what happens if the charge different sign attract each other? So how can we sketch the lines? How? Okay, the lines must be minimum 2. Okay, let's say if I want draw 4 is okay. Then arrow must be from positive to negative. Okay, next. 1C. Figure to show 2 point charges. Point charge mean actually this will be capital Q here. Okay, then determine the resultant electric field at point A. So, what we need to do is first, at point A, at this point, we need to label or we need to place one positive Q0 first. Second, we need to draw arrow to show electric field produced. Okay, let's see. This is positive Q0 and then this is negative Q1. So what happened? Okay, the arrow should be attract each other. So draw. Okay. Then we need to label E on Q0. So that's why label as E1, the direction on Q0. Then what happened between positive Q0 and the positive Q2 here? So repel each other. So to show repel each other, so must draw the arrow like this. But we focus on the Q0. So that's why label as E2 here. Next, check. These two arrow located at different axes. Okay, different axes. So means we need to do resolving vector. Okay, concept. Electric field is vector, so that's why we need to write E equal to K modulus. So here we put modulus KQ over R square. So be careful here. Capital Q mass the point charge or stationary charge. Okay, now calculate E1. Okay, using Q1 over R1 square, and then the distance here between point A to Q1. Alright, so the distance here is from point A to Q2. This is the R2. This is R1. Okay, so substitute all the value here, R1 and R2. This is Q1, this is Q2, then get the answer. Okay, next, construct table. 0, this is negative because of downwards. Okay, this is negative because of left. Alright, then total up here, and then find the resultant at S and Y. Then calculate the magnitude and the direction with the statement. Question number 2. A 4 microcoulomb particle with mass 1.22 gram traveling horizontally at constant velocity. So the concept is acceleration equal to 0. Therefore, the force should be equal to 0. Then the velocity is 5 meter per second. Then enter upward uniform electric field. Explain quantitatively and then label a diagram. Okay, first refer to the concept. Constant velocity, acceleration 0, therefore the net force on the charge is 0. So by using this diagram, we can see here this particle traveling like this, horizontally. So because of what? Because of we have two forces here acting on the charge. Electric force acting upward because of positive, negative attract each other. Then we already know the weight always downwards. So refer to the uniform electric field. KY, I draw the parallel plate because of uniform electric field. Alright. Then here, so look at the answer here. So this is the upward electric force. This is the downward weight. Okay, refer to the concept net force equal to ma. Then substitute acceleration with 0. So we get net force 0 here. Okay. Then Fe upward positive. Okay, this is negative. Refer to downwards. So therefore we get QE equal to mg. Alright. So why we get QE here? So because of electric field strength equal to F over Q, test charge. When we rearrange, so we get F equal to QE. Alright. Then next, look at the question B. Alright, okay. So, show three charges Q1, Q2, Q3, and then the distance between them is 12 centimeter. Calculate potential energy of the system. Okay. So refer to the concept of electric potential energy is scalar. So we will use U energy equal to KQ1 Q2 over R. So because of we want to determine the energy for the system, so this is the energy between charge 1 and charge 2, energy between charge 2 and 3, energy between 3 and 1. Actually, refer to the diagram here. So we need to determine in cyclic 1 and 2, 2 and 3, 3 and 1. Alright. Okay. So using this equation, and then Q1, Q2, the magnitude. Okay. Then we get in joule. Question number 3. Okay. State relationship between electric field strength and the electric force. Okay, now look at the equation related to the definition of electric field. Okay, this is the relationship between electric field strength and the electric force. Okay, next. Two positive charges PQ are separated at a small distance. Magnitude of charge P is 4 times of charge Q. Sketch the electric pattern formed around the charges. Okay. So refer to the diagram here. Consider the magnitude P greater than Q. So now what happened? Okay. Sorry, here should be positive. Okay. Here should be positive. So now what happened? So the charge will repel each other. So let's say this is 1, 2 with arrow outward. So this is become 1, 2, 3, 4, 5, 6, 7, 8. Okay, to show the number of electric field lines for this one is 4 times rather this one. Okay, next question 3b. So 2-point charges Q1 and Q2. One positive, one negative, are placed at point X and Y. So look at this diagram. X Q1, Y Q2. 1. Determine potential difference between RS and the work required moving positive charge. Okay, from S to R. Okay, now we want to determine potential difference. So the concept is delta V equal to V final minus V initial. Then the electric potential or potential difference is scalar quantity. And then this is related equation. So be careful here, Q must point charge. Alright. Now, we need to determine the electric potential at point R. And then we need to determine potential, electric potential at point S. Alright. Okay, how? So VR1 mean and VR2 means, okay, we need to calculate electric potential Q1 R1 to Q1. Okay, this is VR1. And then R to Q2. This is VR2. Okay, this is distance R1. This is distance R2. Okay, next. Okay, we need to calculate S, electric potential at S. So this is VS1 and then this is should be VS2. Then this is R1, this is R2. Okay, so how? So now this is the net electric potential for point R. Okay. Then substitute Q1, R1 here. And then this is the electric potential at point S. So here from Q1, here from Q2. And then be careful here, distance from point S, distance from point R. Okay, last part. Okay, delta V equal to VR minus VS. So determine your answer in volt. Next, we need to calculate the work required in moving charge 2 microcoulomb. So meaning this moving charge is your test charge Q0 from S to R. So S become initial point, then R your final point. So that's why look at the equation, related equation. So delta V equal to work done S to R over Q0. And then here look at the final minus initial. So final is R, initial is S. So Q0 refer to this one. Okay, find in Joule. Okay, question number 4. What is meant by equipotential surface? So equipotential surface in which all points have same potential. Okay, next. for A to Roman. Calculate work done required to bring a charge 3 microcoulomb. So consider this moving charge is your Q naught. From infinity, so infinity become your initial point to 0.5 meter from a charge Q. So this one is your final point. Okay. So work done. So we use work delta V equal to work done over Q naught. Then the equation of electric potential KQ over R. So be careful here. Q is point charge. Okay, so we need to determine delta V, so final minus initial. Okay, now look at the Q. Okay, we only has one point charge. So this is the point charge here. And then initial, distance, this is final. So determine your potential difference. After that, using this equation to find in joule. Okay, next question is, okay, two identical point charge, positive Q1 and positive Q2. Okay, are placed X and Y. Okay, sketch the pattern electric field. Okay, because of these two charge equal magnitude. Okay, so positive repel. Okay, minimum two lines. Okay, arrow. Settle. Next, draw the direction of electric force at X. Okay, the electric force at X due to charge Q2 if the charge Q1 is negative. So now, due to charge Q2 if the charge Q1 is negative. Okay, so let's say now we change this Q1. Okay, this Q1 is negative Q1. Okay, so negative, positive, attract. So because of we want to draw the direction, okay, Q1. Okay, due to Q2 means here. Okay, this is the force by 2 on 1. Next, for the question number 5. Alright. Figure 6 show 2-point charge Q1 and Q2. Okay, actually, this one must capital Q1 and capital Q2. Okay, place 15 centimeter apart. If the magnitude of the Q1 and Q2 is 10 nanocoulomb each, positive, negative, calculate potential difference between A and B. So the concept is, okay, delta V equal to V final minus initial. It doesn't matter if you use VB minus VA or VA minus VB. So step 1, we need to determine the net electric field at B. Okay, this is net VNet at point B. Okay, the question is why? Why we need to find the net electric field at B and also at A? Right, the question is why? Because of, here, we have two or more point charge. Alright. So let's say we have two or more point charge. So we need to determine VNet at each point. Alright. Clear? Okay, next. Okay, refer to the distance. Okay, let's say this is the point B. This is the point B. So the distance for each charge. Okay, let's say this is RB point just 1. Okay, then this is RB from point 2. Clear? Okay, then for the point A, this is the distance. Okay, so this is VA from just 1. This is the distance. Sorry. This is the distance RA1. This is distance RA from point 2. Okay. So substitute here using the equation of electric potential. And then same with point A. Then determine your answer. Then minus. Okay. Next, for this question. Okay. Show the 3-point charges. So this is the point charge. Actually, this is not point charge. But what? But this is the test. Actually, this is the test charge. No, sorry, test charge. Alright. So copy figure 7 and sketch the path of the 3 charges. Okay, 1. The concept here, 1, look at the magnitude. Okay, compare. This is 1, magnitude 1. This is magnitude 2. This is magnitude 1. Alright. The second concept, look at the types of charge. Okay. This is negative, this is negative, this is positive. Okay, then look at the plates. Okay, now this is positive plate, this is negative plate. That's why when we look at the electric field line is from positive to negative. Okay, now we need to draw for the first moving charge or test charge. Okay, this is -1, magnitude 1. So how? Okay, this is 1. Okay, the green color, this is the 2. sorry. Okay, this is must be curve more. This is 2. Alright. And then this is for the